Hey guys, this is the Spiral Review for Spiral 2. I've modified this a little bit, so I'm recording a new video to see how this goes. Also using Chromebook instead of iPad, so this may get a little bit choppy. First up, we got a sketch graph whose domain is -4, 3, 5, and 9, and whose range is -6, 4, 5, and -2. Just remember, these are the x values. Oh, this is going to be fun. These are the x values, and these are the y values. And that they don't necessarily have to tie exactly together. But these are the only x values and the only y values we can use. The easiest way for me to see that is maybe to take a look at this as, okay, -4 goes with -6. It doesn't have to, but again, that might be one way to do this. So you get the point, -4, -6. The next one, I might use -3 and 4, and again, you don't have to use this order, but this would be one way to do this. That would be 5, 5, and 9, -2. So if you were to do this, you end up at the point -4, -6, somewhere down here, 3, 4, somewhere up here, 5, 5, like that, and 9, -2. Somewhere down there. And this would be fine as a function. There are no overlapping points. And all of the x values and all of the y values are represented. To make this no longer a function, what we're really talking about is adding another point so it fails the vertical line test. Any other point that we have is a same x value, whether it's 9, 0, or something similar, would end up causing that to be an issue. For a second one, my graph looks different than yours does, and you might notice that now that you're seeing this in color, in that I have an endpoint here that you cannot see, and an endpoint here that you can. So first thing we've got to do, the domain and the range. The domain looks like it starts at -2 and goes all the way up to +5. Because I have clean endpoints there, we're going to stop there and not continue onwards. For the range, we're going to start at -1 for the y, and we're going to go all the way up to +5. As far as whether or not this is a function, yes, this is a function because there are no repeated x values. Okay, continuing onwards, we're looking at function operations and composition. Let's do the function operations stuff first. So we've got to find g of f of 4. What this really means is that we're going to find f of 4, which means we're plugging in 4 for x in that function, so f of 4. And whatever we get, we're going to plug it into g. So working from the inside out. 2 times 4 is 8. 8 plus 1 is 9, so we got 5/9. Okay, and again, we're going to take this and plug it into the other function. So that's the square root of 1 minus 5/9, which is the square root of 4/9, which is 2/3. That's your final answer. The second one, this is my least favorite notation in the world. This just means f of g of x squared plus 1. And when we go to plug some things in, we're going to see what happens there. So I'm going to plug x squared plus 1 into g of x first, and that's going to look like the square root of 1 minus x squared plus 1, which happens to give us the square root of -x squared. This doesn't actually work so well as a function, but that's okay. We're going to keep going with this as though this worked out nicely. And pretend that I didn't mess up when I made this problem a couple years ago and forget to change it every year since then. So I've now done the g of x squared plus 1. Now we're going to plug this into f. So f of the square root of -x squared would end up being 5 over 2 square roots of -x squared plus 1. And in fact, you can just leave it like this and call it a day. Okay, g of h of f of g of 2, we're going to work on the inside out again. G of 2, I'm going to go over to 2 and go down to g, and oh, that happens to be 2 as well. And that means I'm going to plug this in to my next thing. So that's going to be f of 2, because that's the answer I got. And f of 2 is also 2. Okay, that's kind of weird, but that's okay. I'm going to then do h of, and use that 2 that I got as an answer, not because I'm doing the same problem over and over again, but because that's what I keep getting as an answer. And h of 2 happens to be 3. Finally, I'm going to do g again. Then we'll do g of 3, and g of 3 is 3. Okay, we're going to do 2 times f of g of h of 0, and then plus 3. H of 0, do this in a different color. H of 0 is 1. So 2 times f of g of, we just found out that was 1, plus 3. G of 1, so it's 1. G of 1 is 2. 2 times f of, we said g of 1 was 2, plus 3. And now I'm going to look up f of 2. So f of 2, 2, f of 2 is 2. 2 times 2 plus 3 is equal to 7. Next up, we've got to do some transformations of graphs. The first transformation we have is a random graph of f of x. In fact, this is the same one from the first page, so it's highly possible you can't actually see what this looks like. I've got the point -2, negative 1 here. Up top, because it's a nice point to choose, is 5, yes, height. 1, 5. The next point that I think you see is going to be 3, 3, and I don't know if you can see this last point, 5, 3. So I'm going to pretend that that point doesn't exist, just for the sake of this video. Okay, I'm going to do this point by point, and we're going to start with 1, 5. I know that the inside is going to be based on what the x value is, and here, that's going to end up moving to the right and have some kind of a stretch going on here. We have a shortcut that says we can set the inside. I'm going to distribute this 2x minus 2 equal to the old value. And when we solve this, we get x is equal to 3 over 2, or 1.5. The y value, let me do this one in blue, I'm going to take care of with the stuff on the outside. So we've got -1 for the negative f, times my y value, 5, and then plus 3, which happens to be -2. My first point is going to become 3 over 2, -2. So that's like right here. This is the point that used to be up top, apparently, because I totally went out of order, which is awesome and helpful. Next point, we'll do in yellow. I'm going to do -2, -1 this time. So the same setup. Old x value, -2, is equal to 2x minus 2. That's the inside of this function. I'm going to add 2 to both sides, divide by 2, and I get x equals 0. The y value is going to be -1 multiplied by -1. That's from the y value. Plus 3, which is 4. My next point is at 0, 4. Let's put that up here. So 0, 4 is going to be right here. And again, this is this point used to be. So you might get an idea that we're going to come up here and then maybe come back down. And if I was doing this leg, I would end up with another point there. My third one we're going to do in green. and that's the point 3, 3. Okay, I'm going to do the x first. And we get 2x minus 2 is equal to 3. I'm going to add 2 to both sides and divide by 2, and I get x is equal to 5 over 2, or 2.5. For the y, we do negative 1 times 3 plus 3, we get a y of 0. When I go up to my graph, that's 5 over 2, 0. And that's going to be right here, which actually goes kind of nicely with what we were expecting from our graph overall. Finally, I guess I'll do the last piece. We are looking at the point 5, 3. So 5, 3. The x would be 2x minus 2 is equal to 5. If I add 2, that's going to be 7. Divided by 2, x is going to be 7 over 2, or 3.5. I probably want to get the y one first. And then the y value, get negative 1 multiplied by 3, plus 3 gives us another 0. So 7 over 2, 0. Which is going to end up being at 3.5, adding the L part to my graph. You might notice this graph is now flipped. By the way, now I'm explaining the transformations. This graph has been flipped over the x-axis. That's the negative part. It's been squished. It's twice as narrow as it used to be. That's that 2. It's been moved over 1 unit from where it used to be, and up 3 units from where it should be. Finally, we've got a similar setup here where we've got points at negative 1, 1, 1, 1, and 0, 2. My graph is going to have negative f of x minus 2 minus 1. I'm going to do this one using just the transformations. And the reason I'm going to do that is because we don't have any weird stretches on the inside. That's going to be kind of the key to set off between doing something using this type of thinking or doing something using just the transformations. We do the x's and the y's again separately. So x's are going to be all the points right 2 units. The y values, I'm going to multiply by negative 1. And then after I multiply by negative 1, I'm going to go down 1 unit. Let's see what that might look like. So for negative 1, negative 1, positive 1, right 2 units would be at positive 1. Multiply 1 by negative 1. Okay, that's negative 1. And down 1 is negative 2. So this point is going to become 1, negative 2. My next point, 0, 2, I'm going to go right 2 units, and that's going to make it 2, something. Multiply by negative 1, okay, that's negative 2. Down 1 is negative 3. So my second point is at 2, negative 3. You may have noticed for the last one that I wrote positive 1 and then I graphed negative 1. What was I thinking? I wasn't. That's the problem. So I fixed that, which is nice. And we got to do our last point. We're going to use red for this one. 1, 1, 2 units to the right is going to be 3, something. Multiplied by negative 1 is going to be negative 1. Down 1 is negative 2. 3, negative 2. You might keep in mind what these points used to be so that you can come up with a pretty good graph as a shape afterwards. which might look something like this. Maybe you will actually hit the points even though I didn't.